Okay, we are here with Rita to talk about interpreting proportional relationship graphs. You ready to go?
Yeah.
Okay, so a proportional relationship, remember, is going to be in the form y equals kx, where k is some sort of number. So it's y equals 3x, or y equals 2x, or y equals 7.9x, or something like that. And when you graph it, it's always going to be points that line up in a straight line that goes through the origin, okay? And so
Okay.
now sometimes we're going to see these kinds of relationships in the real world, and we want to interpret them. That means just to say, what does this mean for the real world, okay?
Okay.
So let's look at this situation. We have a description and a graph. Let's go ahead and read the description. The following graph represents the distance traveled by two hikers. Y represents the distance in miles. So let's just pause right there so we understand that here on the y-axis, this is the distance in miles, okay?
Okay.
And x represents the time in hours. So, okay, so these numbers over here are the time in hours. And let's just think about that before we read too much further. So there's some hours that some hikers are going, and then there's the distance that they go in those hours. Does that make sense?
Yeah.
Okay, good. So that's what this graph is all about. Now it says find the unit rate for each hiker, and then it's giving us a whole bunch of other questions, so we'll come back to this, but let's read through them. Then write an equation for each hiker's distance, and find the miles each hiker would travel after 15 hours. And then it asks us which hiker's pace is faster. So there's about 5 questions in there, okay? And this is a
Okay.
really good example of a strategy in math, especially with word problems like this. And that is, my advice is just slow down. So don't try to have your mind solve everything at once. Instead, slow down and write things down, one step at a time. Okay, so let's
Okay.
start doing that. So the first thing is it says find the unit rate for each hiker. So I like to create a place where I'm going to be writing this stuff that's really nice and neat. So what I've done over here is I've written there's the blue hiker right here and the orange hiker right here. And the first thing we're finding is the unit rate. We'll find some other stuff and we'll write that down here, and we'll put our information in here. Make sense?
Yeah.
Okay, good. So let's first think about that unit rate. Now remember, a unit rate is in something like miles per hour. It's things per one thing. And that's why it's called a unit rate, because this is just one thing. The per thing, like hour here, or miles per gallon, or other things like that, is just one unit. So we want to find out how many miles each person goes in 1 hour. And the hours, was that on the x-axis or the y-axis? Let's ask ourselves that. What do you think?
The x-axis.
X-axis. Remember, the x-axis was about the amount of time they were going in hours. So we want miles in 1 hour. So we can go to the x-axis here, and we can go to 1 right here. Okay?
Yeah.
So let's go ahead and put those points on the graph here. So here you can see now the graph has, for both the blue hiker and the orange hiker, there's the point where x equals 1. Okay? Now, for the blue hiker, it looks pretty obvious that there's a number of miles that the blue hiker goes in 1 hour, and you can read it right off of the graph. What is that?
2.
2 miles. Okay, so let's go over here, and let's go ahead and write 2 miles per hour is the unit rate of our blue hiker. How many miles they go in 1 hour. Does that make sense?
Yeah.
Okay, now back over here for the orange hiker, it's a little bit harder to read off of the graph. You're going to be doing kind of an estimate by looking at it, but what do you think it is about?
It looks like a half.
A half a mile an hour. So let's go ahead and write that over here as kind of our placeholder amount. And now while we have that there, let's just make sure, because sometimes with graphs you don't want to estimate, you want to see if you can get to an exact value. If we look a little further up the graph, when x equals 2, what does y equal?
1.
1. So in 2 hours, the orange hiker goes 1 mile. So it's 1 mile in 2 hours. And that makes sense that it would be 1/2 mile in 1 hour, right? So that makes sense. So our unit rate for the orange hiker is 1/2 mile an hour. Okay, now let's go back to the problem. The next thing it says is write an equation for each hiker's distance, okay? So let's set up a place to do that. So we want an equation, and the thing is, remember, with a proportional relationship, your equation is always going to be in the form y equals some number times x. Well, the great thing is that you can use these unit rates because those are the same thing as that number. The unit rate is going to be the same as the constant of proportionality. Okay, so what would our equation for the blue hiker be?
Y equals 2x.
Right, it's just our unit rate times x, and that's what y will equal. And let's just make sure that that makes sense to us by looking back over at the graph here. So when x is 1, we multiply 2 times 1 and we get 2. Okay, great. So when x is 2, we multiply 2 times 2 and we get 4. Does that look like it makes sense?
Yep.
Let's jump up here to 4. When x is 4, we multiply 2 times 4 and we should get what?
8.
8. So let's go up here and do we get 8?
Yes.
Yep. So it looks like that's the correct equation for the blue hiker. Now let's talk about the orange hiker. Remember, we're just going to use the unit rate to write the equation. So what do you think the equation should be?
Y equals 1/2 x.
Very good. Okay, and let's just make sure that that's true also. So let's go back to the graph. And we already said that when x equals 1, y equals 1/2, and that's 1/2 times 1. That makes sense. Let's jump up here to some even number to make the math easier. What's 1/2 times 6?
3.
3. So is that 3 there on that graph?
Yes.
Okay, and let's jump up to 10 then. What's 1/2 times 10?
5.
5. And so we go up here, and yep, that's the y value, 5. Okay, so it looks like we've got the right equation. Great. Okay, now the next thing. And find the miles each hiker would travel after 15 hours. That's an interesting question. Sounds like a long hike. Well, if the graph here, if x went up to 15, we could just read it off of the graph, but x doesn't go up that high. The great thing, though, is that you can just use your equation. So you can put 15 in for x here to find how many miles the blue hiker would go in 15 hours. And you can do the same thing by putting in 15 over here for the orange hiker. So let's go ahead and do that. We'll have a nice, neat space to do that. We'll label it distance after 15 hours. And we just what's called plug in 15 for x. And so we have 2 times 15, and that equals 30. So how far did the blue hiker go in 15 hours?
30 miles.
30 miles, right? And then how about for the orange hiker? What do we multiply by what? I'm sorry?
So y equals 1/2 times 15.
1/2 times 15, good, and that is 7.5. So how far did the orange hiker go in 15 hours?
7.5 miles.
7.5 miles or 7.5 miles? Excellent. Okay, and then the last thing that the problem asks us is which hiker's pace is faster? So what are your thoughts on that? We'll go ahead and label this area. Well, actually, it looks like we actually put it up here. But you can see that the blue hiker has a faster pace, right? Because in 15 hours, they went 30 miles, but the orange hiker only went 7.5 miles. You can also see that because their unit rate is greater, 2 miles per hour versus just 1/2 mile per hour. And you can also read it from the equation. The coefficient in front of x is greater here than the coefficient in front of x here. So those are all ways that you can see that the pace is faster. One last thing, which one of these lines would you say is steeper?
The blue one.
The blue line, okay? So that's another way to think about it. When you're thinking about pace or unit rate, the steeper lines, the one they're going up and to the right, are the ones that have the greater unit rate, the greater coefficient, the greater distance after a certain amount of time, and the greater or faster pace. Does that make sense?
Yeah.
Very good.